Hello friends, welcome back to the channel. In this video we are going to discuss and implement application load balancer for AWS EC2 instances. We will start by discussing the basic structure and basic settings required for the implementation of application load balancer, and we will also discuss about the common mistakes if your EC2 instance is not reachable or your application load balancer is not responding. So let's start. Here is the basic structure. For every AWS EC2 instance, we are having a defined VPC. Your instance is launched in a defined VPC or virtual private cloud, and under virtual private cloud you are having various availability zones, and under that availability zone, or we can say under every availability zone, you are going to have a default subnet. This is the basic structure, and under that default subnet, if you are not selecting any VPC availability zone or the subnet, your instance will be launched under the default subnet of that availability zone. So this is the basic structure. You may create your own VPC and you can select your defined availability zone, and you can also create your own subnet. Next important thing is route table. The route table is defined with the router, and the router is associated with the particular subnet. So this route table is defining the routes for your EC2 instance to communicate through the VPC or through the internet gateway. So this route table is playing very important role. Whenever you are creating a VPC or you are using a default VPC, the VPC is connected with the internet gateway. The internet gateway is communicating with the internet, and your route table is defining the routes for the communication of your EC2 instance with the outside world through the internet gateway. Now let's discuss the basic routes defined for your route table. The basic routes are: destination is VPC CIDR, means the default route defined in your route table is for the VPC as destination, and the next hop in the path is local. To reach this VPC, you can have the next hop within your virtual private cloud, means within the same VPC a local hop is defined. This destination means that to reach this destination from a node, you are having a next hop. So this next hop is target, and destination is here. So this target is defining just the next stop for your communication before reaching the destination, right? So you must clear about these terms why we are defining this thing. So this target is not your source. This target is defining the next hop in the path to reach this particular destination. For example, if your VPC is 172.31.0.16, then the destination defined in your route table is like this, means this is the VPC CIDR address of your VPC, and the target is local. But this connection will not make your instances visible to the outside internet, means your EC2 instances are able to communicate internal locally to your VPC, but they are not visible to the outside world. To make them visible to the outside world, you need to define another route in the route table as this, means here the destination is any traffic. Here 0.0.0 means any traffic from the internet, and to reach any traffic from the internet, this is any traffic from the internet, the next hop in the path is internet gateway. So the first line, this first line is defining the path to the VPC. The second line is defining that to communicate with the outside world, you need to go through the internet gateway, means the next hop is internet gateway. So this entry is making this path possible. After this entry, your EC2 instance is visible to the outside world because your subnet is public. So this setting is required to make your subnet visible and to make your subnet public. You might have other subnet with other route table but not having the gateway entry. That subnet will be your private subnet. If your subnet is having the entry for the internet gateway and the destination as 0.0.0, then that subnet is your public subnet. and this is open to connect with the outside internet. So this is the basic root structure for any EC2 connection, but you need to make your subnet as public. So you can define your own root table, or you can change the default root table by adding this rule. Now let's see the steps required to implement the load balancer. So here load balancer comes to the picture. Means if we have the traffic and we have the need to offload the traffic among different EC2 instances, traffic should be divided among multiple instances, then you need a load balancer, and the load balancer will divert the traffic to multiple servers. So for implementation of load balancer, we need to make certain changes. First step is to create a security group. This first security group will be linked with the load balancer, and the second security group will be dedicatedly for your EC2 instances. So first step is to create a security group for your load balancer, and the second step is to create a security group for your EC2 instances. Let's see the inbound traffic rules for these two security groups. For the security group of load balancer, we need to add inbound traffic rule, as this must allow HTTP traffic from anywhere. For anywhere as the source, it must receive the HTTP traffic. So this is the only rule need to be defined for the inbound traffic rule of your security group linked with your application load balancer. And second thing is the security group for your EC2 instances. For that you need to make inbound traffic rules, as first is receiving all SSH traffic from any source. Second rule is receiving HTTP traffic from your security group linked with the application load balancer. Means you need to make entry for this security group to the EC2 security group. This security group is supposed to receive the traffic from the load balancer security group. So these two rules need to be defined with your second security group, and this rule need to be defined with your first security group. And for the third step, you need to launch two EC2 instances within the second security group. Means the security group defined for the EC2 instances. So here we will be launching two instances. You may have more than two instances, and we will not select any availability zone. In case if we are not selecting any availability zone, then these two instances will be launched in the default subnet of the defined availability zone. And I am going to use the default VPC, default public subnet, or the subnet is not public. We will be making it public by adding this rule. So you need to make the subnet public by adding this particular rule or path to your internet gateway. Next thing is you need to create two security groups, and you need to select your default security group while launching your EC2 instances. You can also use the default security group, but sometimes it might create confusion because you need to edit the attached or associated security groups for these settings. So sometimes students make mistakes, so it is very preferable to create your own security groups for load balancer and for your EC2 instance. And next thing to make sure is that your root table must be associated with the subnet, and your subnet must be public. So let's start. Firstly, we will complete these three steps, and then we will move to the further steps by creating load balancer and the target group. So for this setting, we are going to run this bash script for both of our EC2 instances. For first instance, I am going to write server 1, and for the second instance we will be writing server 2, just to check whether our request is forwarded to server 1 or server 2 through the load balancer. So let's start by creating security groups and your EC2 instances. This is my AWS console. So let's start by checking the default settings. I am using the default setting. You may use your own VPC, own subnet, own root table. So here I am having only one VPC running. So this VPC is available and the ID is 2387. My VPC's ID is 2387. Next, I must have internet gateway associated with this VPC, and here is my internet gateway. It is attached to the same VPC. You can check the VPC ID is 2387. Next, I need to have the subnets. Here I am having 6 subnets defined in different availability zones. If you can check, here we have different availability zone. So here by default for a particular region I am having multiple availability zone, and every availability zone is going to have a default subnet. Your instance can be created in any of these availability zone, or you can select your availability zone and your instance will be launched in the default subnet if you are not providing your subnet. And next thing to make sure is the root table. So here is my root table. It is associated with, let's check the subnet association. It is associated with the subnet, and it is also linked with the same VPC. So subnet association is also there. Subnet is associated with the root table. Here the root table is associated with only one subnet, that is your CC4C2. You can also associate the same root table with multiple subnets by editing your subnet association, but we are not changing it for now. The first step is to add this root to your root table. So here is our root table. Let's check the roots. Here only one root is defined. As we discussed, this is the CIDR for my VPC. So let's edit the root and add root. Now we need to add the root as we discussed, destination as 0.0.0 and the target as internet gateway. So let's start. Destination as this and the target as internet gateway. Now it will ask for the ID of your internet gateway. As I am having only one internet gateway, select the same and save changes. Now this root table is associated with the subnet with ID this, and this subnet is now the public subnet. Okay, means this is the default subnet of a particular region, but now it's public too because we have added the root to the internet gateway. Now next step is to create security groups. One is for the load balancer and one is for the EC2 instances. So let's start by creating the security group. Here we need to give the name demo security group for application load balancer. You can give any name, any description. Let's give the same. And VPC, it is showing the same VPC because I am having only one default VPC. Next step is to define the inbound rules. So add rule, and as we discussed, we need to add the rule for receiving the traffic, HTTP traffic from any source. So I am providing it as HTTP traffic type, and source can be, select the source as custom and then anywhere, means you are open to receive HTTP traffic from any source. And next step is simply to create the security group. You can also provide the tag for naming convention if you want. For example, I am providing a name as this, and next step is to create the security group. So my first step is done. Security group is created. Now coming to the second step, create another security group. I am giving security group for EC2. Let's give the same for description, same attached to the same VPC, and we can also add the name, same as name. Next we need to add the inbound rules, and for this we need to add rules for the SSH traffic and the HTTP traffic from the first security group. If you remember, we need to add the rule to receive traffic from SSH traffic from anywhere and HTTP traffic from the first security group. So here SSH traffic from anywhere. Next, add another rule to receive HTTP traffic from your first security group, and for this you need to select custom, and here it will prompt you for different available option and you need to select your security group. This is my first security group defined for the load balancer. So my first two steps are done, means I have created two security group, one for load balancer and one for the EC2 instances, and then create security group. You can check here my security groups are created: demo security group for EC2, demo security group for application load balancer. Now third step is to launch EC2 instances. For that, select EC2, launch instance, give a name, select AMI, instance type, key pair, and this auto assign public IP should be enabled. Here you need to check for the network settings, as we are keeping the default VPC. We are not providing any subnet. So this instance will be launched in the default subnet of the availability zone, and make sure the auto assign public IP is enabled. Now next step is to select your security group. As you are creating EC2 instance, so you need to select the security group existing and select your security group, demo security group EC2. Last step is to add your bash script to advanced details. So here is the user data section where we will be adding this. Just copy this script. And here we have the server 1 for our web 1. That's okay. Launch instance. Now let's create another EC2 instance. Web 2. Select Amazon AMI. Key pair. Now we need to select the same security group defined for the EC2 instances. We are not selecting VPC subnet. Next, go to advanced detail and paste the same script. Just make a slight change. Instead of server 1, we will be writing server 2, so that we can see the difference where our request is launching with EC2 1 or second instance. Launch the instance. So now we have two instances, one is running and other is still pending. So let's check the next step in the process. So the fourth step in the process is to create the target group. Load balancer has to choose the instances from the target group. So next step is to create the target group, and the fifth and the last step is to create a load balancer and link it with the defined security group and the target group. Then for every request, your load balancer will select one of the instance from the target group. So let's quickly create the target group for the fourth step and the load balancer for the fifth step. Make sure the target group should contain your EC2 instances, and your load balancer must be linked with your first security group and your target group. So let's start. Go to your target group. Here you have the target groups in the same EC2 dashboard. So target groups, create a target group. I am going to create a target group for the instances. Give the name. HTTP. It is connected to the same VPC. Protocol version is HTTP1. Health check. Now here, for the health check, you need to define path, as our instances are having the path of index.html as /vad/www/html. So we need to just copy this path and paste here. So this will be the path of our index.html for both of the instances. So here just define the path and click next. You can also define tag, that's optional. Now it is showing the running instances to add to your target group. So just click on both the instances, as we are willing to add both of the instances as our target group, and the ports for selected instances is 80. Just click on include as pending below and create target group. Now our target group is created. We defined 2 EC2 instances or the targets, and you can also check the details over here. The registered instances are here, web1 and web2. Health status is still unused. So after the 4th step, creation of target group, we need to move to the 5th step, where we are going to finally create the load balancer. So go to load balancer. Here currently I am not having any load balancer, so create load balancer. We are going to work with application load balancer this time. Create, give a name, and internet facing IPv4. This it is linked with the same VPC, and you need to select all the subnets. As we had not selected the availability zone, so your instances can be part of any of the availability zones. So you need to select all the availability zones, and here come the important step, where you need to select the security group defined for your load balancer along with the default group. So here you can select up to 5 security groups. So I am selecting the default one, it was already there. And second, I need to select the security group created in the first step. Next step is to select the listener. So we are listening to all HTTP traffic, means we are up for the HTTP traffic from the port 80 for our target group, that is your demo target. We had created this group demo target with 2 of instances. So you need to select the target group and the security group defined in the first step, and the target group defined in the 4th step. And after that, you can check the brief summary of your load balancer over here, like internet facing IPv4, default security group, and the default security group, and your custom security group, and all the regions. And next is you are listening to the port number 80 for the demo target group. So this is all your summary for your load balancer, and click on create load balancer. So your load balancer is successfully created. Click on the load balancers. Here the status is provisioning, so you need to wait. So you may refresh, as it may take a while to turn the status to active. So now the status is active and your load balancer is up and running. So for details, you can select the load balancer and check the details as status is active, VPC, IPv4 availability zones are all listed over here. And last, you need to copy this DNS name. You can also copy the DNS name from here. For earlier practical, we were using DNS of your EC2 instances, but now your EC2 instances are not directly reachable. We are reaching them, or we are accessing them through the load balancer. So you need to access the DNS of your load balancer. So now copy this DNS. You can copy it from the detail or directly from here. So simply copy it and paste it to the new tab. As you can see, our first request was forwarded to server 2, means your second EC2 instance, not to first. If you refresh it, your next request may go to the same server or to the first server. So it again go to the second server. So the third request is forwarded to your first server. So this is load balancer's work. It is offloading the task among the two servers. You may have more than two servers defined in your subnet, but now we have only two EC2 instances. So request is forwarded either to first server or to the second server. Here you can check. So that's it for this video. I had used the default VPC and default subnet. You may create your own VPC with your own gateway, own subnet defined, own route table defined, or you can practice this with the default one as well. Just you need to change the route table. Second thing, you need to create two security groups. You may also change your default security groups of load balancer and your EC2 instances, but sometimes it is a little bit confusing. So it's better to create your own security groups for load balancer and your EC2 instances, and rest you just need to create a target group and a load balancer. So that's it for this video. Hope you have learned something.